Like, why do you think there's more seconds in a day? How could we figure that out? Time is longer. Sure. How long is time?
It's a day is 24 hours and
Okay.
a mile, I don't know. It depends on how fast you're going.
Okay, I like that. So a day is 24 hours and a mile depends on how fast. So you're saying speed is a factor, right?
Yeah.
Does anybody know how long a mile is? Like how many feet are in a mile or something? And time is more infinite. I like that.
55,000?
Oh, say it again.
55,000 feet in a
50
mile?
is a mile 55,000 feet? Yes. Yeah, about that. 5,000. Oh no, you're saying 55,000. I'm thinking the
I know there's 1,760 yards in a mile.
that's the one. Yeah, we're thinking that. So 1,760 yards in a mile. I was thinking what I was thinking of whoever said that before, the 55,000, I'm thinking the 5,280 feet in a mile. There's no reason I should know that, just from random classes have taught. Ooh, okay, Cade said there's 63,360 inches in a mile. How did you do that, Cade? Did you just look it up? Google. Yeah, sure. Google is our friend, right? So there's that many inches in a mile. What about seconds in a day? We know there's 24 hours in a day,
About 72,000 seconds in a day?
72,000
About.
seconds per day. About that. Do you guys agree with that? Seems right to me. Oh, 86,000. Is that what you got from Google, Nadia? Haha, yeah. Hey, you were right there. That's a pretty good estimate. So the real time number is 86,400 seconds in a day. But either way, answering the question is correct. So it's really interesting with a question like this because even if you kind of estimate a number, you can still get the right answer because either way, both of those are much higher than 63,000. So there's definitely more seconds in a day. You guys are right. Very good. Good job. Go math. Woo. All right. So, first things first that we're going to kind of talk about today is just what's due this week. We have our live session and then your math mindset lesson where you watch the video and then just answer a question about it. And then you have 3 lessons in Math Excel: equivalent fractions, adding and subtracting fractions, and multiplying and dividing fractions. And I know fractions can be really, really, really icky for some people. And we're starting to get into the types of math that, you know, if you're not the type of person to add stuff in your head super fast and all this, that's fine. There's a lot of resources out there to help you, you know, but you still kind of need to know the rules behind it and how we do it. So we'll go through the lesson and then I'll show you a really cool online resource to help you guys out. Who would say that um, adding fractions or adding stuff in their head is a strong point? Who can add like really quickly? And if you don't want to answer, you don't have to. Kate, I got that impression with how you've been answering. Very cool. Okay. Anybody else? I am definitely not this type of person. I like to have things in front of me, write it out, all that good stuff. Okay, who's less mental mathy and more write it all out, have it in front of you, understand the rules. Yeah, interesting. And there's strengths to either side. That's really cool. Cade, were you finding the integer lessons fairly easy with going through them pretty quick? Yeah, that's cool. It's a good strength. It's good to get to that point. But, if you're not like that, that's okay. Lots of resources. That's what's cool about online school is you don't have a teacher. Like I can tell you until I'm blue in the face. No calculators and all that good stuff, but could you potentially use a calculator? Yes, you could. It's what's beautiful about it. That's what I would do if I was stuck, but we still got to know the rules. All right. So, this is what goes in your planner. So take a minute, guys, and write that in your planner. Okay, we've got the math myths in the brain. That one's an easy one to get done. If I were you, I would, bam, get both of those done today, the live lesson and that math myths. Then we've got equivalent fractions, adding and subtracting fractions, and multiplying and dividing fractions. And it's kind of up to you where you put it within your week. So you could say that, Thursday is going to be fractions day and get it all done. Or you could do a little bit today, a little bit tomorrow, a little bit Friday. So go ahead and write that in your planner wherever you do your plannering. And all that. I'm just going to take a quick peek at our class list. I want to make sure everybody is present and accounted for. I think we're just missing. What? That's how many seconds are in a year? Oh, we were saying a day. That's right. I was like, wait, what were we saying? Wow, that's a lot of seconds. Jeez. And it doesn't seem, guys, does that number seem low for a year to you, like for you? Like I look at the number and I'm like, really? I would think it'd be much higher. Even though that is a really big number, but what do you guys think? Does that number surprise you if there's 31,563,000 seconds in a year? If you say it, it sounds bigger, but if you see it, it doesn't look that big. What do you guys think?
It sounds a lot smaller than it should.
Yeah, I totally agree with that. That's so interesting. Interesting.
Google says that.
Google is wonderful. I Google everything, even random facts. Like, what did I Google the other day? Oh, my daughter started dance class, and okay, this might be an overshare, but I didn't know if you're supposed to wear underwear under your leotard or if it's like a swimsuit, so I Googled it. And then I felt weird for Googling that. What's the weirdest thing you guys have Googled that's super school appropriate, obviously?
I once Googled how many balloons it would take to float a person.
That's a good one. That's a really good one. Very good question to Google, especially after like movies like Up and all that stuff. Very good. But that's a house. That's different. Interesting. What about the rest of you guys? Any interesting topics we've Googled before? Oh, Nathan, you are back, my friend. Can you hear? Evan. That's a great one. How much tinfoil you would need to cover, huh? Did you guys know there's like weird things you can do to Google? Or if you got like the no YouTube.
One time I Googled, like I saw this thing, and then I Googled Florida man, and it was just a bunch of like, things that this guy did with like in Florida, where he would like steal alligators and things like that.
Oh my gosh. Oh my gosh, that's hilarious. It's funny looking up stuff about people in Florida. Like there's all these things about weird things that people in Florida do. There was another one, the people of Walmart. I've looked up where I shop at Walmart, so I don't know why there's, but I probably look like one of those people when I go in there shopping in my pajamas. Oh yeah. There's like different ways you can break Google or something too. You can type in different things. I forget what it is. Like break Google Gravity. That's what it is. Yeah, here, should I show you guys? If you type in Google Gravity, watch this. Are you ready for this, guys? Oh, and then you click on Google Gravity. I broke it. Oops. Or like, there's Google Black, I think. There's a lot of different neato things about Google. Pretty cool. Now everybody's trying to break Google.
If you look up Wizard of Oz and you click on the like shoes,
Oh, that's right. That's right. I remember that. Wizard of Oz.
and then click on the red slippers over there.
Ah, that's so neat. Did you guys see that? That's so, did you hear that too or no? That's crazy. Isn't that cool? Someone fishing in a pond that's gonna go, oh, okay, that's funny. There's like alligators and stuff on ponds there, right? And Nathan, I still don't know if you can hear us, friend, if you can. Okay, who are we missing? Is it just Owen? Okay, Marina's here. Ava's here. I keep doing this and then losing track of who I'm checking. Chase, Owen is not here. Kate is here. Nathan's here. Evan is here. Addie's here. Freya's here. Nadia, Jaden, and Emma. Okay, it's just, oh, Cade's not here. But Cade, come back. Okay. All right, so did you guys all write that down? Okay, good. Did you write that in planners and all that stuff? Because we're going to start talking about equivalent fractions. Who hates fractions? I've always hated fractions.
Me.
Yeah. Oh my gosh, yeah. Yep. I've always hated fractions, always. I don't know why, if it's just the idea of comparing two numbers or having to do things differently, it's always like, bleh. But then I became a teacher and then I taught them over and over again, and only then did it start making a little more sense. So I'm with you. But we'll get through it as painlessly as possible. Oh, I didn't think that would affect my slides. I apologize. Let me just scooch this over here. I have two screens that I'm working off of. Okay. Does anybody else have the multiple screens set up? It's handy. I recommend it. But not required at all. It's just neat to do. Okay. Need to find my screen pen thingy. Where did you go? There we go. Okay, so, oh yeah, it's pretty nice, right, Freya? I like it, but it makes you look like you're always looking weird there. Okay, so with the multiple screens. So if you have a second computer screen, you can hook it up to your laptop just by plugging it in. I have an HDMI cable, just because that's what the laptop takes. Otherwise, you just connect the screen right to your laptop. Mine uses an HDMI cable. There's a lot of different types of cables. Most commonly, it's an HDMI cable. And then you plug it on in, and then you can go to. Do you have an HDMI cable? Do you know what that is? I didn't before I did this, so no judgment there. Okay, yeah, if you plug the monitor in to the HDMI thing on the computer, and then you go to, what is it? Here, let me exit, and then minimize all this stuff. There we go. This. Okay. So then you guys can see my screen, right? If you right click on the screen and then go to display settings, and then you can identify multiple screens. You can, for multiple displays, I choose to extend these displays. You can duplicate, but extend gives you more room there. So yeah, that is what I recommend. It's pretty nifty. Okay, let's talk fractions so we can get through this. So first thing that we want to have written down in your notebooks or a piece of paper or whatever, again, with fractions and with math, I recommend writing stuff down. It always helps. It does not help to take pictures or to save screenshots. It just doesn't help because you don't look back at it. But if it truly does help you, no judgment there. You do what works for you. But I recommend writing it down, keeping a math notebook. So equivalent fractions are fractions that have the same value even though they look different. So things like 1/2. 1/2 you can kind of visually see here. And I'm going to click my pen up there. How 1/2 is the same as 2/4, because a 1/2 chunk of this bar here is made up of 2/4. We're just dividing it up a little further, which is also the same as 4 of these eighths. So they are fractions that have the same value even though they look different. If you think about it mathematically, if you take a fraction, and you can make an equivalent fraction, you can multiply that fraction by any number to get an equivalent fraction, but you have to do the top and the bottom, okay? So if you want to make an equivalent fraction, multiply by the top and the bottom. So I could continue this. I could multiply the top by 2 and the bottom by 2. And 4/8 is the same as 8/16. What would be an equivalent fraction to 1/3? What do you guys think?
2/6.
2/6. Good. What did you multiply the top and bottom by there?
2.
By 2. Yep. If you multiply by 2, got to do the top and the bottom. That gives you 2/6. Good. 3/9. Yep. You multiply by 3. Very good. What else? What other fractions can you get by 1/3? It looks like we have people that have multiplied by 2 and by 3 so far. Okay, multiplying by 10. You're right, Chase. If you have 1/3 and you multiply by 10, that leaves us with 3. Or excuse me, I can't multiply. 1/30. No, 10/30. Sorry. My goodness. Let's clear that off so that it looks better. Jen. Get your brain going, Jen. My brain glitched out for a minute. Okay, I'm back now. So 1/3. We multiply by 10 like Chase suggested, and we get 10/30ths. There we go. That looks better. 11/33. Very good. Multiplying by 11. Yeah. You got it. So you could multiply by any numbers with a fraction to get an equivalent fraction. Good. So equivalent fractions are fractions that are the same even though they look different. Same value. Okay. So when you have a fraction, most commonly where you're going to use this is you will have to write a fraction in lowest terms. That's what your first fraction assignment is about. Equivalent fractions. It's all writing in lowest terms. There's only 7 questions. Yay! So to write a fraction in lowest terms, there's a few things. Sometimes you look at it and you just know. Like if I have 15/30ths, if I looked at that and I would say, what can I divide both the top and the bottom by? What number? That's the question you want to ask yourself. By 5, right. Someone wrote a 5 on there. Good. So the question is, what can I divide both the numerator, the top, and the denominator, the bottom? So what can I divide by the numerator and the denominator? Okay, and let's say you know. And it looks like this person who's writing on the screen knows. It's 5, definitely, very good. If you divided 15 and 30 by 5, that would lower this fraction. So we would go 15 divided by 5 gives me 3. And then 30 divided by 5 is 6. So now we have lowered it to 3/6. So now we got to ask ourselves another question. We're going to ask ourselves, is there another number that we could divide the numerator and denominator by?
3.
By 3. You got it. Very, very good. So if we divided both the numerator and the denominator by 3, so we divided by 3, we divided by 3, we would end up with 1/2. Good. And then you can ask that question again. Is there another number? And in this case, guys, is there another number we could divide both the top and the bottom by? Or are we done? Did we get as low as we can? We're done. Yeah, we're done. That's as low as you can go. So in this case, we're at 1/2. So that's one way to do it, is just to say, what can I divide it by? And let's say you don't know. Here's where you might take a calculator and start dividing. 15 divided by 1. Well, 1 would work, but 15 divided by 2. Nope, that's a fraction, right? That's a decimal. It doesn't work. 15 divided by 3, and keep going that way. Another way to do it is if you list all the factors of the numbers. So what I might do is I might first go, okay, factors of 15, 3, 5, I think that's it, right? And then 15 and 1. Those are the main things. So the main factors, the main ways that you could multiply to get 15 are 3 and 5. What about 30? You could do 2 times 15, right? 3 times 5. So there's a lot of ways to get that. Oh, 15 also counts as 1. I should really put that up there. And then 1. Ah, it's overlapping. No. Oh my gosh, cut it out. Ah, okay, well, You get the idea. So another way is to write out the factors, okay? So what are my numbers that could multiply to be the top and the bottom? And then check for the ones in common. So after writing out the factors, I can say, look, 15 is the biggest factor in common. So I would divide the numerator and the denominator by 15. And that gives you 1/2. That's another way you could do it. I prefer the first way. I think it goes a little quicker and it's a little easier to think through. What do you guys think? Who likes to just think about what they can divide the top and bottom by? Or, better way to put this, who prefers the first method? And who
Me.
prefers the second method? So just put a 1 or a 2 with which method you prefer. Okay. And it helps me to see it because then I can show you. So you like both ways, Evan? Oh, we're kind of divided. That's really cool. Very cool. Sometimes if it's like numbers that are unfamiliar, it's helpful to list out all the factors. Very good. Okay, do we have this written down, guys? Can I switch the slides? Perfect. Okay. If you are still writing, remember you can always go back and watch the video or just hang out and I will pull the slides up again. All right, so let's go through and do these. Let's talk about number 3 for a second there. That one's an awesome one. What's awesome about that? We can simplify that so easy. Like I know right away that I can cancel something out of there. Does anybody know the trick when you have two numbers that end in 0 with a fraction? What can I do?
You can divide them by 10.
Right, very good. So for the first one, since both of those numbers have a 0 at the end, whenever they have zeros like that, that means you can divide by 10. But basically, all that you have to do is just cross off those zeros. So you're left with 5, 6. It's a rule in algebra. Whenever you have the same over the same, it cancels itself out. So we had a 0 over a 0 canceled itself out. What we're really doing is we're just dividing by 10. So if I listed the factors of 50, I would say probably 1, 2 times another, 2 times 25, 3, 4, 5, 10, 25, 50, something like that. And then for 60, I would kind of do the same thing. 1, 2, 3. 60 has a lot more factors. 4, no. 5. Yes, 5 is 1. This one takes a little bit. What you're doing is you're just continually dividing. So you're going 60 divided by 6, 10, 12, whatever. We would keep going. But then we see that 10 is the highest factor that they have in common. So that is what we would divide by. Very good. Go ahead and take a second, guys. And what factor does number 4 have in common here? What number do they have in common where I could divide there? What do you guys think? Evan and Nadia say 3. And even if it's not the highest, that's totally fine. You could just pick one and just go from there. But they are saying 3. So let's start with 3. Let's do that. If 3 is in common, that means we're going to divide the top and the bottom by 3. So what is 18 divided by 3? 6, good. And what's 27 divided by 3? 9. Oh, look at that. Can I divide any more? Do 6 and 9 have a number in common? Yeah, 6 and 9 can also be divided by 3. So we didn't pick the biggest factor, but that's okay. We can keep going. We just keep going until you can't divide anymore. So 6 and 9 also can be divided by 3. So we're left with 2/3. That's our answer. Very good. What about number 5? What could I divide number 5 by? What number's in common there? You don't have a lot of options for that numerator. So yeah, let's try 3. What is 3 divided by 3? What is that? 3 divided by 3. What is that going to give me? 1. Yep, same divided by the same is just 1. What about 24 divided by 3? Yeah, that's 8. So we're left with 1, 8. By the way, if you're not the quick integer type in your brain, if it takes you a little bit, is it okay to have a calculator next to you while we're doing live session? Or your phone calculator? Is that okay with me? Say yes.
Yes.
Okay, beautiful. Yeah, absolutely. You can have a calculator in front of you. Totally fine. Seriously, that's what I would do. Whatever helps. All right, what about 8/12? What is in common there? Those both numbers are even. So what could I start dividing them by? I gotta do 4. 4 is the highest, but what if I didn't know it was 4? 2, yeah. I would pick 2 because they're both even numbers. So if I divided by 2, 8 divided by 2 is 4. And 12 divided by 2 is 6. Oh, 4, 6. What do I have to divide by again? By 2. Yeah, so that leaves me with 2/3 when you divide. What about number 7? What can I cross off on those? What's the matter, baby? My kitten's meowing at me. Hey, you. What can I cross off on those? What do you think? Emma says the zeros. Do you guys agree with her? Can I cross them off? Someone did, yeah. Why can I cross off those zeros? What do you guys think? Yeah, they can be divided by 10. Very good. Then we're left with 3/8 when I divide by 10. Very good. Hello, baby. My kitten wants to see you guys. She says hello. Oh, she's purring. She's 8 months. She thinks she's the star. She'll probably jump up. Yep, there we go. I apologize for the cat butt in your face. Okay, move it. Okay. Kitty, kitty, kitty. All right. What about 8 and 48? Oh, I love kittens. Yeah. How old are they, Freya? Are they just babies? I remember when she was so small. She's still pretty small. But she's getting big. Yeah, someone wrote on there divide by 8. Very good. When your numerator is smaller, usually that's a good, oh, Freya, that's so sweet. That's a good indicator of what you can divide by. So 8 divided by 8, what does that give us? It would be a 6 on the bottom. Yep, and 8 divided by 8 is 1. So you would be left with 1/6. Very good. Nice job with that, you guys. All right. Now we got to talk about adding and subtracting fractions. Yay! So when they have the same denominators, you're in business, right? All we have to do is add up the numerators and copy the same denominator, okay? So 1/5 plus 2/5 is just 3/5. You add the numerators and keep the same denominator, and it's the same with subtracting. Subtract the numerators and same denominators. You could even have some integers in there, so you could get negatives as well. So just make sure you're prepared for that. Okay, so if you have the same denominator, you just add or subtract the top and keep one of the same denominators there. That is the process. So what would I get for number 1 there? What would I get? 2/7 plus 3/7. Yeah, 5/7. You're right. We add, thanks for writing that on the screen, by the way. So we add the numerators and keep the same denominator. What about the next one? 9/14 plus 1/14. Yep, very good. 10/14. Uh-oh, and what am I going to have to do now? Because 10/14. Both of those numbers are even. So what should I do to my answer? Simplify it. Yeah, you got it. You always got to have your answer simplified in a math world, right? So 10/14, if we divide both by 2, because they are even, that should get you as low as you can there. You shouldn't have to simplify too much. So what would you be left? Oh, 5/7. It's like right in front of my face. Oh no, it's the same as the other one. Look at that. Crazy. I totally planned it that way, right guys? No, but that's good. Very, very good. Okay, what about the next one? 1/6 plus 3/6. Four, 6. Very good. And we got to do what? Because they're even. Got to simplify it again. Yeah, what would you get if you simplify 4/6? Emma's got it. Good job. Divide by 2. Yeah. 2/3. Yep. Nice. Very good. Okay, what about that last one? I wrote it in kind of weird, like, here, let me get my pen up there. So this one's really saying 3/6 minus 5/6. And you might be tempted to reduce this one, but don't do that because then you'll have different denominators and you don't want to go there. So leave that as 3/6. We like those same denominators. So we're going to subtract the top 3 minus 5. And we learned from last week that any subtraction problem we can change to addition, right? What would this look like as an addition problem? And really, it's just that 3 minus 5 that we're dealing with because the denominator is going to stay the same. So what is 3 minus 5 as an addition problem? What would that look like? I don't remember if that was this class where someone said KFC. Keep, flip, change. 3 plus 5 is almost 100% correct. We still got to put that negative somewhere. Which number changes to negative? -5. You're right. Very good. We keep the first one, change your subtraction to addition, and change that sign of the second number. So 3 plus -5. Good. And then we keep the same denominator. So 3 plus -5. That's like saying I have $3, but I owe Ava $5. So do I still owe Ava money? I owe her $2. Very good. and it's over 6. So we have negative 2 6. Am I done? Is that my final answer? Negative 2 6. Yep, we got to reduce it. It divides by 2, so we reduce it to negative 1/3. Good job, guys. Very good. All right. Keep it cruising. Okay, so now if you have different denominators, now we have to get the same denominator. So we write out all those. Okay, so we have an addition problem with different denominators. So we have to rewrite it with a common denominator. So we think about what multiplies to be 6, 6, 12, 18, 24, you know, all the multiples. And then we think about what multiplies to be 9, 9, 18. And then we can see that 18 is the lowest number that they have in common. So that means those fractions need to be rewritten to have denominators of 18. And once the denominators are the same, then you can add them. So let's do that. So for the first one there, 4 and 6, let's think about those multiples. What are my multiples of 4? What do we get if we count by 4s? 4 times 2 is? What do you guys think? What are multiples of 4? 4, 8, yep. 4 times 3. Oh, very good. Good. 4, 8. Don't forget 12, but 16, 20. Good job, Emma. 24, 28, and 32. Good. What about 6? Ooh, and someone's putting out there, they think 3. Let's see. What are my multiples of 6? 6. 6 times 2 is? Oh, okay. Someone's putting on there that they think if they multiplied the first fraction by 3 and the second fraction by 2, yeah, 6, 12, 18, 24. And we can stop because what multiple is in common? It looks like we've got that 12 in common, right, guys? 24 is in common too. Yeah, you could do 24, but you don't have to. I would pick the lowest one, which is 12. And it looks like this person said, well, if I want to change the denominators to 12, that means I have to multiply the first fraction by 3 and the second fraction by 2. So you got to focus on what denominator you're trying to get first. Okay, so 4 times 3 is 12, and whatever you multiply the denominator by, you got to do the same to the numerator. So 2 times 3 is 6, and then the next one, 6 times 2 is 12, and then you do the same to the top. So you get 6 twelfths plus 6 twelfths, which equals 12 twelfths, which is just 1 whole. Very good. That's a good one. All right, let's do number 10 there. What do you think I should get those denominators to be? If the denominator is a 4 and a 2, what could they both become? And you could figure that out by listing all the factors. Some of you might see it. What do you guys think? Oh, let's not skip ahead. I'm not saying you're not being brilliant. I appreciate it, but let's not skip ahead because we're probably not going to do all of them on here just in the interest of time. What do you guys think? If I listed the factors, I'm talking about number 10 here. If I listed the factors of 4 and 2, the multiples, I would go 4, 8, 12. Oh, they're already up there. You're right. And then I listed the factors of 2. I'd go 2, 4, 6, 8. So what is the lowest multiple 2 and 4 have in common? What is the lowest multiple? Which is 4. Yeah. 4. That's the lowest multiple they have in common. So the first fraction, I don't need to worry about. It already has a 4. But how do I change the second fraction to have a denominator of 4? What do you multiply by to get from 2 to 4? Emma says it's 2/4. What do you multiply by? Multiply it by 2. Yeah. 2 times 2 is 4. 1 times 2 is 2. And then we could do the subtracting. 3 minus 2 is 1/4. Does that make sense, you guys? Okay, in the interest of time, what I'm going to do is I'm going to skip ahead because I have to show multiplying and dividing really quick. I'll just show you the process. If you are still having trouble with this, if you have a question, just hang out and I'll go through a few more with you, okay? So to multiply fractions, you just multiply straight across the top, straight across the bottom, and then simplify. That's it. Nice and easy. Multiply across the top, multiply across the bottom, and simplify. That is the multiplying process. So what would I get in number 2 here if I multiplied? We're going to multiply straight across the top, 8 times 1. And then 3 times 2. What do we end up with there? What do you guys think? What's 8 times 1? 8/6. Yeah, very good. You would get 8/6. And then we have to reduce that, right? I know technically it's improper, but you don't need to make it a mixed number unless it asks for it. But you can just reduce it as it is. So we would reduce by dividing by 2. So you get 4/3. Good. Multiply across the top, multiply across the bottom, bing, bang, boom, you are done. Now, dividing is really similar, and this is the last thing we're going to talk about. All that you have to do, it's the same process as multiplying, except you take the second fraction and you flip it. So they'll say invert it, but we just flip it. And then we change our division sign into multiplication. So it goes keep, change, flip. Keep the first fraction the same, change your sign to multiplying, and flip the second fraction. And then you just multiply like usual. Okay? All right. We are 2 minutes over. So if you have questions with that still, hang out, let me know, and I'll do a few with you. Otherwise, you are free to go. Thank you for hanging out. Again, I apologize for running late. It will not happen next week. Promise you that. I'm starting to be on the mend, but you guys have a great day. Thank you for your attention and your participation. You guys are awesome. Oh, no problem, Freya. No problem. Nathan, could you hear us at all? I'll have to maybe give you a call and just see what's going on there. Bye. Have a great day. Oh, thank you. I'm on the mend. Cade, any questions? I'm going to keep blabbing into my microphone here and my videos.
It just won't let me leave because I have annotate.
Oh, because you have what?
I had annotate on because I was drawing on the screen.
Oh, it's my tricky way of making you stay and talk to me all day. No, I'm just kidding. Well, you have a great day, okay?
Yep.
Are you able to leave now?
Yeah.
Okay, good. Good. Well, you have a good day. Okay. Well, for my friends who decided to keep watching here, I'm going to keep going a little bit just to show, just in case you're having some issues with this. So we're going to clear it and go to our practice. Okay, so we want to divide these fractions. So what I'm going to do is I'm going to keep the first one the same, change this to multiplication, and flip this one. So keep, change, flip. So then I multiply straight across. 1 times 3 is 3. 14 times 2 gives me 28. And I cannot reduce that any further. Now this next one, same deal. Keep, change, flip. I'm going to keep this first one the same, change this division to multiplication, and flip this second one. Then we multiply straight across. 49 over 8. And I cannot reduce that any further. That is all. So that's all I have for you, lovely folks. You have a wonderful day. And yeah, thanks for being awesome again. Okay, bye. I'm going to stop recording.